Hello. Good to meet you. I am Mori from Toyota Tsusho. Thank you very much for this opportunity today. Now, different from Denso's presentation, I would like to be more on the business side as I make this presentation. Several years ago, we started our businesses relevant to quantum computing and try to advance the use of it. So let me introduce something that we have done. Well, the first slide is not of your interest, but this is my self-introduction. I lead the Smart Society Business Promotion Department, and as you can see from the term, Smart Society means future society. We are building new businesses for that. I joined Toyota Tsusho in 2000, so it's been more than 20 years. And I was in different countries like Singapore, Thailand, China, the US, and Israel for about 12 years in total. And last year I came back to Japan to be in this position. So here is the outline of the company. The company has the name Toyota. So the Toyota Motor Company is the biggest shareholder. In 130 countries in the world, we have different businesses. Smart Society Department. Well, actually, the company has 7 lines of business plus corporate department. And Smart Society reports to the Chemicals and Electronics Division. Safe and secure, enriched future to be built using quantum computing is our mission. New solutions are to be developed. New businesses are to be developed by this group that I lead. Now, within ourselves, we have a quantum project team members, 8 of them, as you can see, in Japan, 5 from Toyota Tsusho, including myself. And Nexty Electronics at the bottom is the 100% subsidiary of ours. So here's an engineer. And Toyota Tsusho Mobility Informatics is a Singapore-based mobility service developing company. We have 2 engineers from there to be a part of this team. So much for the introduction. Let me talk about our quantum computing businesses. Here is a summary page. Now, quantum computing itself is not what we handle, because for us, quantum computing is a tool which can be leveraged to generate new businesses for us. Quantum annealing and quantum gates are both within our interest, and both of them have priorities different in 2 regions. In terms of quantum annealing, for mobility businesses, solution development can be done using this technology. Well, this audience does not have to be told that within the mobility industry, we have had multiple problems like congestion as well as production planning, where combinatorial optimizations were required. And recently, cars are more connected, and mobility as a service, or MaaS, is offered. So cars are being used in different ways. And easing of congestion, last 1 mile delivery planning, these more complex combinatorial optimization problems are increasing in number. So the instantaneous computation of such problems is a big need from this industry. So several years ago, we started finding partners in developing application of quantum annealing, and we have conducted several POCs. Now we are finally seeing how we may be able to capitalize on the power of quantum annealing as a part of our competitive advantage in developing concrete solutions. In the near future, we will be able to launch quantum annealing-based solutions into the market. Now, on the right-hand side is the quantum gate technologies. Now, the hardware itself is not ready yet. It takes more time. So, in the area of quantum annealing, we are ready to come up with real-life solutions, but in the area of quantum gate, we have to set our horizon a little bit further. So, easy-to-use gated quantum computing environment should be built together with invigorated ecosystems and so forth. As for the quantum gates, our target areas would not be the mobility that I talked about earlier, but quantum computing for exploration of materials, as well as methodologies for exploration. So these are the areas where we want to apply quantum gate technologies. Now, I'd like to share with you some case studies of what we have done. First of all, about quantum annealing. We have been involved in the Nitto Project. In 2018, this project started. From different industries, we have problem of combinatorial optimization. An efficient solution to those requires commercialization of Japan-made quantum computers, and a full-stack solution had to be built with AIST and universities and private sector companies. So we are all involved in this Nitto project. Within this, what we do is, especially in the area of mobility, mobility users do have concrete problems, as you can see on the right, like delivery planning, congestion easing, taxi matching, scheduling, and so forth. So these challenges are extracted so that we can collect data and offer that, as well as icing model formalization and coding. So this is something we currently do. And in different problems, we are now building a generic data set which can be used for different purposes in this arena. Now, the next example is a collaboration with partner companies. In Thailand, taxi and trucks carry GPS probes, and we collect geolocation data from those beacons so that we can offer real-time traffic information as a service. And we have the data of past 10 plus years because of that project. So we work with Fixters and Denso. We are now working on POC of optimization of delivery routing. TTMI is our subsidiary to Tsusho Mobility Informatics. So they have this fleet management algorithm, which runs on which is a classic algorithm running on classical computers, and Fixters developed Amplify, annealing engine, and the quantum algorithms run on that Fixters Amplify, and those two are compared. And on the right is the TTMI on classical computer and Denso's quantum algorithm on D-Wave hybrid solver. And the outcome of the two are compared, as you can see on the right. It may not be obvious what has improved, but in reality, the computation time is several-fold better using quantum annealing, as well as amplify compared to classical computing. So we arrive at the answers faster, and the accuracy of the output in terms of the number of vehicles necessary for deliveries, as well as delivery time and driving range. In all of those KPIs, using quantum annealing or pseudo annealing, we arrived at better results. So this is our collaboration within the private sector. So we are building solutions and use cases which are attractive to our customers through these POCs. Therefore, we are currently building solutions which can actually be applied to our customers' settings. Now, let's talk about quantum gates. As I mentioned earlier, we still do not see any solutions which are ready for the production usage. We are waiting for the evolution of the hardware in this field. But still, we are building the ecosystems as well as the environment which would be ready for the hardware for gated quantum computing later on. So one of the things that we are doing is our collaboration with Kinesis. Kinesis has a booth outside. In Japanese quantum computation, Kinesis develops algorithms and support engineering. So this year in May, we decided to invest in Kinesis and signed the capital participation agreement. From our perspective, Kinesis, as a developer of algorithms and engineering in quantum computing, Kinesis certainly is a leading company. So, for chemical-related companies, together with Kinesis, we are developing possible solutions. Of course, we have other partners who offer tools and solutions. Our material informatics process, therefore, combines elements from different vendors, and Kinesis is a very important partner here. So this is one of the endeavors that we are currently putting in place. Kinesis has built Q-Park ecosystem for new material development using quantum computing. So it's an ecosystem of the interested companies. Within this community, basic quantum computing usages as well as use case proposals are being considered. We sponsor this community and runs this community together with Kinesis. Through such endeavors, the quantum computing, we believe, is an area where we have to expand the addressable market, involving lots of education and enlightenment, so to speak. About the collaboration with Kinesis, we focus on offering value to our customer based on quantum computing. But other than that, from the user's perspective, we build environment to make the usage of quantum computing easier, and we build ecosystems with different partners both in and outside of Japan. So let me give you an example of that. Hardware, software, middleware. The wide range of layers require promising partners, and we are in search of good partners all the time. Most recently, as you can see on the left, we started a collaboration of quantum computing controller with quantum machines from Israel. So we signed an agreement to work with them to develop Japanese market for them. Outside, you see the actual machine offered by Quantum Machines. So please stop by at our booth and take a look. And on the right, as you can see, the Quantum Software Research Hub. In 2021, the Cabinet Office announced the policy on enhancing quantum software and promised to build multiple hubs in Japan. So Osaka University is one of the university partner which has joined in that initiative. So within this, we are a participant, and a sub-project leader comes from Toyota Tsusho. Now, Bleximo is a hardware developer. You see their booth outside as well. In the future, in the longer-term horizon, eventually quantum computing can become more dedicated for different applications, and thus becoming mini quantum computers for different areas. So that's a vision that they're developing, and we work with them. And QCware, the organizer, we work with them outside of the quantum chemistry in different areas. So when it comes to quantum gate, it takes time to develop for the technologies going forward, and we have to get the market ready for that. And we have to work together with different companies to enhance awareness for this technology. And also it's important to come up with use cases where such quantum computing can be effectively applied. So for the next several years, we will focus on doing that. So let's summarize. I talked about quantum annealing and quantum gates, where we are active developing use cases in the different phases of quantum computing. First of all, we have to start out with the education of what quantum computing is and how it can be used. So we offer workshops, trainings, and the comparison of quantum computing and classical computing in POCs in the validation phase and in the production phase. Going forward, the quantum computing itself must be democratized together with the solutions and tools of our partners. And we continue to build solutions based on quantum computing, which would be valuable to our industry customers. So in different phases, if you're interested in working with us, please let me know. Thank you for bearing with me with my non-technical presentation, but I've summarized what we are currently doing in the area of quantum annealing and quantum gate computing to getting ourselves ready with lots of use cases being built. With this, I would like to conclude. Thank you very much.